Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's learn about multi-architecture or multi-platform container images using Docker. So we will learn how to create multi-platform Docker images, how to deploy them, and we will see that through a demonstration. Now, before we learn about multi-platform container images, it's worth revising our understanding on what is Docker and how Docker evolved. So let's go 10 years back, where one of the major problem in the IT industry or in the software deployment or the release processes, it works on my machine. So this used to be a very classic problem. Developers, QA engineers, system administrators, they all used to fight on this called it works on my machine. What is this problem? Let's say there is an organization called XYZ. And within this XYZ organization, assume there is a developer and this developer is working on a Java application, adding a new feature to the Java application on his personal machine or on developer's Windows laptop. Assume this is Windows 8. So developer works on this feature for some time, adds lines of code, and finally one day developer is confident that okay, the feature development is complete. So developer tests this by running some Maven build targets on his local machine, creates a jar file, then deploys a Tomcat server on his Windows machine, and finally deploys this jar file onto the Windows machine. Developer tests all of these, application works absolutely fine. So developer decides that, okay, before I promote this application onto production, let me ask one of the QE engineers, quality engineers, to test this application, test the feature. And to do that, back then, developers, along with the system administrators, used to create a document. And this document has the steps, such as the first step can be how to install Maven and how to run the Maven targets to build a jar file. Then how to deploy a Tomcat server, and then how to deploy the jar file onto the Tomcat server. And at this point of time, developer, let's say, has JDK 1.5. Okay. Now this file is shared with the QA engineers, and system administrators created a server, a Windows server for the QA engineers, so that every time someone asks them to test a particular feature, they can log into this Windows server and they can test the changes. Similarly, system administrator created multiple Windows servers so that QA engineers are not blocked. At a time, if multiple QA engineers has to work, or dev environment, staging environment, production environment, so system administrator created multiple such servers. And these servers were with configuration, let's say Windows 10, just for example, and JDK version is 1.6. Similarly, 1.6 and Windows is 10. As soon as the QA engineer installs MVN, it works fine. But then when the QA engineer tries to build the source code by downloading it from SVN, because QA engineer has JDK version 1.6 and developer has JDK version 1.5, there were some compilation issues. And also the Windows was also different. Here, developer personal machine is on Windows 8, whereas the Windows server is on Windows 10. Similarly, there can be hundreds of packages modules with configuration or the version differences. Now, there is a fight between developer and queue engineer. Queue engineer creates a ticket, but developer says, see, it works on my machine. You know, I have run all the steps in the document and it works absolutely fine on my machine. Queue engineer says, I'm not aware of all those, right? I tested it on the Windows server that is shared by the system administrator. I ran the exact same steps. You can look at the screenshots and it does not work on the Windows server. So this used to be a major challenge for the system administrators, and it used to take them hours of debugging, because here I explained you explicitly that developer had Java or JDK 1.5 and the Windows server was 1.6. But imagine if this information was not known to the system administrators and they got this issue. So they have to debug the developer's machine, they have to debug the QA machine, they have to look at the differences. There can be hundreds of packages, hundreds of MVN plugins, anything can be different. So system administrators used to spend days together debugging such issues. And trust me, it used to be a very big issue. It works on my machine. So system administrators were hugely relieved when Docker came into existence. Of course, I should say containers here, but a lot of people, when I say containers, they relate to Docker. So that's why I'm talking about Docker. And we'll also use Docker as a platform in this video. So when Docker came into existence, it was a huge relief to the system administrators, because now they don't create this document and they don't share it with the queue engineers. Instead, what the system administrators used to do is they used to write this Docker file, or developers used to write this Docker file. It doesn't matter who it is, but in the Docker file, because there is a base image, and this base image had all the versions, let's say JDK, right? Now the development team and QA engineers, they don't have to fight with the JDK versions, because in the Docker image, the system administrator says JDK version is 1.6. Whether this Docker file is running on the developer's machine or whether it is running on the QA engineer's machine, the JDK version is 1.6. So if it works here, it works here. Similarly, let's say Maven. There is a specific version of Maven that is put in the Docker file. Base image. There is a specific version of the base image that is put in the Docker file. Similarly, the commands, everything. It can be the JDK properties, the JVM properties. Everything is put in this Docker file. So there are no complaints. And it is a huge relief for the system administrators. And it almost solved their problem. Now, why do I say almost? This is very important, right? And this is where we will relate to our topic multi-platform in this video. The reason why I just did a quick recap of what is Docker, how it evolved, how it solved the problem of software engineering, because Docker at that point of time, it did not solve the problem completely, but it almost solved the problem. Why? Now, even if you take this example, there is a limitation for the Docker images here, or the Docker containers. Both of these architectures or the platforms have to be Windows. Imagine if developer use a Linux platform, right? A lot of developers use Linux machines, right? Or imagine developer use a Mac laptop, Apple laptop. Now, if developer creates a Docker file, right? And if developer creates a Docker image on this machine, this Docker image or this Docker container, which would be a Docker image that is built on AMD architecture, right? It does not work on the Windows server. The QA environments, the production environment, assume if it's Windows environment, it does not work here. And there can be organizations where you have mix of servers, like some of your servers are Linux servers, some of your servers are Windows servers. In this case, system administrators had a little challenge where instead of creating one Docker image, they had to create two Docker images, right? One Docker image for the Linux servers, one Docker image for the Windows servers. Now, this was not a big challenge when you compare to the issue that we were discussing here, right? So, it was kind of okay that developers or DevOps engineers, system administrators, they used to create two images, one Linux Docker image, and predominantly most of the Linux machines that time used to be AMD. I think even if you go back 2 to 3 years, most of the Linux machines were on AMD, and even the Mac, which were using Intel processor, which is typically AMD architecture. And then there is Windows. Within Linux, there can be different distributions such as Ubuntu, Solaris, it can be Debian, it can be Red Hat, Fedora, everything works. If there is a Docker image, it works on different distributions of Linux. So the only challenge that DevOps engineers, system administrators used to face is they had to create two Docker images, and that was fine, right? Create two CI/CD pipelines. Or if you don't have CI/CD in place, manually create two Docker images, and it's it's perfect. But now, now we will talk about multi-platform images. Why? If you look at 2024, right? This is a challenge because now we are dealing with multiple platforms. You have Linux machines with AMD architecture, you have Linux machines with ARM architecture, there is Linux machines, IBM machines with Z processors, IBM machines with P processors, you have Windows machines, right? Today, and with the machine learning workloads, you have multiple platforms, right? And creating images for multiple platforms is again a challenge. I intentionally did not talk about other problems that Docker was solving. Of course, it was also solving problems with what virtual machines had, resource utilization and all. But I would only restrict this video's focus to the this particular topic. Okay, going back. So now in 2024, it is a challenge because you have different platforms. And if you talk about ML workloads, for example, okay, unlike traditional applications, the traditional software development process or a regular applications, web applications, which takes very less time. If you want to create two Docker images, one of Linux and one of Windows, it takes very less time. But machine learning workloads, if you try to create a build for the ML workloads, the build might take a lot of time, sometimes 40 minutes, sometimes 50 minutes, right? And when there are multiple architectures, multiple platforms where the ML workload has to be deployed, imagine 50 minutes multiplied by 10 different architecture types. Although you have CI/CD pipelines, you have to develop that. If somebody is manually doing it, you are talking about a one complete day, which you are going to waste, right? So Docker has come up with a concept called multi-platform or multi-architecture builds. Now, you don't have to write multiple Docker files, right? You execute a Docker command, which I'm going to show you. Of course, underlying, we will learn about build kit, we will learn about buildx, but end of the day, you will in your CI/CD pipeline, you would only run one Docker build command, and this build command will create. I'll also show you that in the Docker Hub. It will create, whether you are on a Mac laptop, whether you are on a Linux machine, it will create AME, ARM image, ARM image, it will create AMD image. If required, it can create, IBM P, IBM Z, different architecture images with one single CI/CD pipeline or one single Docker command. Now, this way, you have multi-architecture images. And the beauty of the multi-architecture images is that although you push multiple images, it will be a same tag. Under the same tag, you will have different layers. And the advantage is that if there is a developer taking or using a AMD laptop, right? For them, for a developer with ARM, for a developer with Windows, for all of them, the image and the tag would be the same. The Docker engine, which is on their machine, at the time of Docker pull, it will decide whether I have to pull the ARM layer from the tag. Should I pull AMD? Should I pull P? Should I pull Z? The command will be exactly same for everyone. They will still run Docker pull XYZ colon V1. Everybody use the same command. But the Docker engine on their machine, it will decide, okay, should I pull the ARM? Should I pull the AMD? Should I pull anything? Now, Abhishek, can you explain one scenario where this is very useful? Absolutely. Let's take open source projects, right? For example, let's take Argo CD. Okay. As a DevOps engineer, assume there is a DevOps engineer working for Argo CD and who builds Argo CD, for example. And if the DevOps engineer has a AMD machine and DevOps engineer created Docker file and built a Docker image and push this Docker image to the Docker Hub, right? Everything is fine. DevOps engineer built, wrote the complete Docker file, built Argo CD, deployed it onto or pushed it onto Docker Hub. And there is one person in India who is using a Windows machine who is trying to learn Argo CD, looks at this image in Docker Hub, pulls this image, tries to run Argo CD locally, and it does not work, right? Because it's not of the Windows architecture. Instead, if in the same case, the DevOps engineer with AMD machine or ARM processor machine creates or runs a Docker multi-arch command, right? Creates a Docker multi-platform image. The same thing would be pushed to Docker Hub with the same tag, but it will have multiple layers. And now this person in India who is using a Windows machine, if runs Docker pull Argo CD, from these layers, the Docker engine on his machine will pull a particular thing and deploy it. We will see this in practice. Let's do it, right? I hope the theory part is clear. What is the reason behind multi-platform images? Now, let's do a simple demonstration where I have my EC2 instance, right? This EC2 instance is a Ubuntu EC2 instance with AMD processor type. I'll copy this. Let me take my terminal so that I show you the processor, right? So I have two different tabs. In this tab, I will do SSH -I in the download folder. So if I just go to downloads, so here I have a pen file called AWS Keeper Ubuntu @ the IP address. So I'll just SSH onto the EC2 instance. Of course, I did not provide the right permission. So let me do chmod 600. Now let me just rerun the command. Cool. So I logged into the EC2 instance. And if I just do uname -a, you can see the architecture type is x86-64. So x86-64 is basically AMD. Cool. And this is my personal machine. If I run uname -a here, you can see here the architecture type is ARM64 because I'm using a Apple or a Mac laptop with Apple Silicon processor. Now what I'll do is first I'll write a Docker file here so that I can show you the problem statement. Within this Docker file, let's say from Ubuntu, and a simple Docker file, cmd. Within the cmd, I'll just say echo I'm learning multi-arch builds. Cool. So let's save this file and let me run docker build. Okay, I'll just do docker build and let me just tag it multi-arch demo colon v1. Let's build the image. This is how traditionally you build a Docker image, right? So it's a very small image. It's built. Now let me just do docker push followed by multi-arch demo v1. And this image, okay, it says permission denied because I did not tag it well. Let me just do docker tag multi-arch v1 to Abhishek F5 slash multi-arch v1. And let's do docker push this. Perfect. Now it's pushed, right? And if we go and verify that on Docker Hub, we should see that. So sign into my Docker Hub, and when I just go to this is the latest image, multi-arch demo. As I go here, I can see there is a v1 tag, and here I can also see that, okay, within this tag, there is only this one image. I'll take this. Let me just take this command, go to my EC2 instance. Where is that tab? So this is the EC2 instance. And here I will just do docker run and this. So your expectation quite generally is that it would work because both of them are Linux machines, but it will fail. Before that, I need to install Docker. So sudo apt update. I'll just copy this command, right? And once this is done, let's run the sudo command to install Docker on this machine. I did not do it because, I just want to do in the video. So sudo apt install docker.io-y, and then we will just add the Docker user and run the Docker image, right? For that, I just need to add the Ubuntu user to the Docker group, sudo usermod -ag docker ubuntu, right? I know I'm going a little fast because we covered all these things in the previous videos, but still I'm trying to execute each and every command. If something is new, please run the video at 0.5 or 0.75x. and I logged into the machine back, because whenever you add the changes to the user profile, you have to exit the user and get back into the user's profile. Cool. So now let's run this command, docker run. No image is available locally, so it pulled the image, which is perfect. After that, you can see no matching manifest for Linux ARM 6.4, right? So it says, okay, everything was fine, but this is AMD 6.4, right? This is a AMD 64 architecture machine, and I don't find the manifest for AMD 6.4 because the image was built on ARM 6.4. And how do we solve this problem? It's very simple in some cases, whereas in some cases it is difficult. I'll cover both of it because you need to understand both the things. In one case, where if you are using Docker desktop, in my laptop, I'm using Docker desktop. So if I just do Docker builder ls, okay, so Docker desktop comes with build kit. Out of the box, it comes with build kit. So all that you need to do is, and you can see here in the build kit, it shows the supported platforms as well. What is build kit? I'll also cover that towards the end of this video. So Docker desktop comes with something called build kit, and this build kit, the supported platforms are ARM 64, AMD 64, AMD 64 V2, and other platforms, right? So just have to do Docker buildx build. Of course, I can directly run build as well, but still Docker buildx build hyphen hyphen platform, followed by, let's just say, Linux AMD 64, comma, Linux ARM 64 hyphen T, whatever is the tag that we have provided, right? What was the tag? Let's tag it as V2 now so that you can clearly see the difference, and dot. So now this Docker image will be built with two manifests. One is for AMD, one is for ARM. And if I run the same command on my EC2 instance, nothing will be changed. I will run the same command and you will see this time the execution will be successful. So let's just wait for the packaging part. Okay, and I will just see if the new image is pushed onto the Docker Hub, the V2 tag. Okay, the V2 tag is not pushed, so I can just include hyphen hyphen push to this command. So I'll just say hyphen hyphen push, and now it should be pushed. Let's see if it is pushed. Let's go back to Docker Hub, refresh. Cool. So we have the V2 tag, and if you click on the V2 tag, you can see within V2 there are two architecture types, right? AMD 64 and ARM 64. Whereas if you go back to V1, okay, and if you see here, there is nothing like that, right? In V2, you have a specific tag which shows the architecture types. That is why if I go back to my EC2 instance and run the same command with V2 tag, it extracts and it says, I am learning multi-arch builds. What did I do? All that I did was I used a different command called docker buildx build, because there is a builder on my machine which is using build kit, and that comes only if you are using Docker desktop. Let me try to explain you what happened under the hood. Okay, it's a very simple thing. So traditionally, when Docker was dealing with this particular problem, initially when Docker was introduced, it used a legacy builder. Okay, or you can call it as pre-build kit era. So Docker, to build, it depend on something called as builder. Back then, this builder was not build kit. Now the builder that they are using is a project called build kit. And back then, this builder did not support multi-platform. Using this builder, if you have to build for AMD, ARM, you needed to do it multiple times. But now, I think with Docker Desktop version 23, if I'm right, okay, with the new version of Docker Desktop, or from last couple of years, Docker switched to something called BuildKit. So this is an open source project. BuildKit is an open source project, which is Docker's new builder. And this BuildKit, all that you have to do is you need to run BuildKit as a runner. It can run on a Docker container. It can run on Kubernetes as a pod. That is what Docker Desktop does for us. If we do Docker Builder ls, you can see that I already have a builder, which is nothing but a build kit instance that is running on a Docker container. How do I know? I can see the driver here as Docker. If you see the driver as Kubernetes, that means it is running on a Kubernetes pod, which you can do. Docker does not do it out of the box. Out of the box, Docker Desktop runs a Docker driver, which is a instance of BuildKit in a Docker container. And this supports all of these platforms. So that's why my multi-arch build, it pushed for AMD AMD and ARM. I pass that in the command. If I pass AMD V2, the multi-arch build would also create a manifest for AMD V2. If I pass RISC V64, it would also create a manifest for this particular arch type. So you have to verify two things. First thing that you have to verify is, do you have Docker Desktop? If you have Docker Desktop, just run Docker Builder ls and see what are the architectures, are the platforms that are supported. And then if you run Docker buildx, build hyphen platforms, and provide all of these platforms or some of these platforms, a multi-arch image is created for you. Within the same command, just use hyphen push so that the images are directly pushed to the Docker Hub as well, so that someone else can use your images. Perfect. So if you have Docker Desktop, it's easy for you. Now imagine if I don't have a Docker Desktop. Quite possible, right? You might be using a Linux machine, just like how I am using a EC2 instance here. Now what is the case? I don't have Docker Desktop, so BuildKit is not available out of the box. You can also verify that. If I go to this machine and if I run Docker Builder ls, it says that, okay, there is nothing like that. You don't have any builder. You don't have BuildKit. In such cases, what should I do? So very simple thing. What you need to do is install BuildKit or install BuildX. For that, sudo apt install docker hyphen buildx. So buildx is basically a wrapper or extension for your BuildKit, and this buildx will interact with BuildKit. I'll show you that. So now if I do docker builder ls, right? So out of the box, it created a driver for us. I installed builder, it created an instance of BuildKit, but that is with Linux AMD architecture only. If you watch carefully, everything is Linux AMD only. But Abhishek, I want to run on ARM processor also. What should I do? Very simple. You don't have to worry. BuildKit is quite capable. If any architecture does not exist here, you don't have to worry. All that you need to do is Docker builder, Docker buildx create hyphen name, provide a name for your builder instance. Let me call it as multi arch, and you need to provide the platform as well, right? So let's provide, sorry, platform as Linux AMD 64, comma Linux ARM 64. This command is also in Docker documentation, so you don't have to worry. Followed by, right? So I have created buildx, create this. I need to provide driver. Should BuildKit run on a Docker container? Then just say Docker hyphen container. If it has to run on Kubernetes, you need to configure Kubernetes and you need to say that it has to run on a Kubernetes pod. But I'm fine with Docker container, right? So driver Docker container, just say hyphen bootstrap followed by hyphen use. What does this mean? So we are saying that, okay, there is another Docker, you have another builder instance as well, but use this as default. If you don't do hyphen use, then it will go to the default one. That's why I'm using hyphen use. You can see here Mobi build kit, which is basically the Mobi is the organization and build kit is a project. So it created a new driver for us, which is called multi-arch. Docker builder ls. See, now it supports ARM 64. It supports AMD. Let's verify, right? For that, I'll create a Docker file on my EC2 instance. And within this, let me write similar one from Ubuntu cmd echo followed by I am learning multi arch with Abhishek.Veeramalla, just as an example. Save it and we will run the same command docker buildx build hyphen platform, and you need to provide Linux AMD 64, comma, no space, Linux ARM 64, right? After this, just provide the tag multi arch demo colon v3. Let's call it as v3 and dot. I hope the command is right. Yep, it is right. I just need to provide hyphen push. Exporting, there is some error exporting the image. It says push access denied. Oh yeah, just do Docker login. It's a new EC2 instance, right? So I just need to do the Docker login and just say the password and just rerun the command. Insufficient scope authorization error. What is missed? Oh, again, I did the same mistake. I need to do Docker tag multi arch demo colon v3 to Abhishek F5 followed by multi arch v3. Just a simple one. Multi arch demo. Is there a typo? Sorry, my bad. Let's do Docker images, right? And we can see multi arch demo v2 here. but there is nothing like this. So let me rerun the command. Docker buildx build hyphen hyphen platform, and this is the tag. So let me say Abhishek F5. I know the reason why it does not show in the Docker images, because when you're using this buildx, and what happens out of the box, it does not store the images in the Docker local store. So that's why when you do Docker images, it does not show in your Docker local store. You need to do additional settings or run additional commands for that. But let's ignore for this video, and let me just do multi-arch demo v3. So now the layers are pushed. Let's go to v3, multi-arch demo, and here I see v3. Now in the v3, I see this particular thing, right? So this is how you need to do it on a EC2 instance where you don't have Docker desktop and you don't have build kit. You can also verify, go back to the ARM processor machine or my laptop. Abhishek, I don't have ARM. How do I test it? Create two EC2 instances, one with AMD, one with ARM. So let's do Docker run Abhishek F5 multi-arch demo colon v3. And it should say I'm learning multi-arch with Abhishek.Veeramalla. And if it says, thank you so much for watching today's video. See you all in the next one. And I'm going to create very exciting content in this month. Everything will be like, something we did not do in the past. All the things that we are going to learn will help you with your resumes, preparation. For example, this video, having exposure to create multi-arch Docker images is something a lot of people don't have. So a lot of open source projects do this, and a lot of companies do this these days. So you can add such things in your resume and talk about build kit, Docker builder, Docker buildx. If you want to quickly revise, just go to the Docker documentation, search for Docker buildx, and you can revise what all we learned in this video. Again, see you all in the next video. Take care. Bye bye.